Hello and welcome to our today's tutorial. I'm Michael Kaiser, Director of Product Management at Kathrein Solutions, and today we will talk about vehicle identification with the Kathrein RFID readers and Kathrein antennas. So day by day, when we have a look to our streets and to our cities, more and more vehicles arrive in the cities and drive on our streets. This means we have a lot of traffic jam and the need to optimize the situation is on the hand. And that's why we need tools to support this. With the next slides, you will see what Kathrein give you to optimize this flow of traffic and to grant access to the right person, to the right cars, to the right vehicles. But first, we will start with some explanation of different words and pronunciations. So when you see ITS, we are talking about intelligent transport systems. So this means how we can handle the transport system in an intelligent way, how we can identify, how we can guide them, how we can grant access for these systems. A big topic is electronic toll collect when we have certain areas like motorways where where we have to pay for the use, or maybe in smart city application when we have to enter a certain street and we have to pay for how to do this, how will be this optimized. We will talk about vehicle registration, vehicle identification, EVR, EVI. These are typical points we will be faced with these applications. We'll talk about automatic vehicle identification because it should be very simple, very easy to identify the cars, the trucks, the motorbikes. We will talk about intelligent parking because running of the cars is nice, but sometimes you have to place it somewhere. And with this parking, if you do it in the city areas, it could be a big problem if you are not guided. And in this case, the intelligent parking interface will give you the guarantee the cars, the vehicles are on the right place, and the payment for this is also in a good condition. Smart city application, a typical scenario which grows more and more, especially for police cars, fire brigade cars, or Red Cross cars, security cars, healthcare cars. When you have a certain area which is not allowed to enter in the city center, for example, and there is an accident and the police or the fire brigade has to enter. In this case, there are typical barriers or other barriers there, which we have to open. And if you have to wait for this and it could be, takes longer, then the best is the car itself will be identified and will say, yes, it's allowed to enter this area because this police car has to go there to support for an accident or for some fire. Then in this case, the barrier should be opened automatically. Yeah. And in general about public transport systems, more and more it gets popular to have some such kind of bus lanes and bus areas where only allowed for buses. And how to handle this, we will see in the next slides. So you see here also some pictures for the tolling system with multi-lane free flow. This means we have, for example, a typical scenario on the motorway. We have 3 to 4 lanes, and we have to pay for the use of these lanes and how to handle this. But although this can be for a city application when you have a certain area, a certain lane in the city, and the usage of the lane has to be paid. Yeah. Typical scenario with a tolling plaza, there's a barrier in front of, and when the car arrives, the car has to stop, and then it will be checked for the allowance. Of course, you can do this with a person sitting there and collecting money, but the easiest way is to do it automatically based on RFID. And parking or access control is also a fast-growing area for RFID, where the cars have to be identified itself, and it could be a public parking area, it could be a company parking ground, or in company area where the trucks arrive to load and upload the goods, and this can be also handled and controlled by RFID. So you see a lot of applications are arriving with typical scenarios where you can catch cars, where you have to identify trucks or motorbikes. And before we start with the different application, we'll have a deeper look on the Kathrein components we offer for these applications. Let's start with the RFID reader. The RFID reader is an electronic unit which controls on the one side the antenna to pick up the data from the transponders fixed to the cars or vehicles. And on the other side, we have the network that this data arriving at this reader will be updated and sent to the backend system, to the database system, to control the flow of the goods or the flow of the cars. Yeah, so let's start with the ARU 3500. The ARU 3500 is the antenna reader unit. So it's an antenna reader, antenna integrated with the reader. We have one unit when a compact housing. We have a dual core 800 megahertz processor. Oh, there's an error here. I have to correct it. This is an integrated antenna, as I said, a 7-degree antenna with 3 external ports. Yeah, this is the unique thing for the ARU 3500. We have a high secure memory module built in. This is a module where we can store keys. For example, if the transponder for the cars are scrambled, then we can handle the keys directly on edge. This means directly on the usage. This makes the system more powerful and faster and easy to handle. We have a high-speed air transmission protocol. This means we can control the flow of data very fast and can handle a lot of cars at the same time or fast-moving cars also. We have a power over Ethernet connectivity. This means we can supply the reader with one cable where we have Ethernet on and we have power on. With one cable, we can supply these units. So as I said, we have an antenna integrated, 7-degree antenna, and we have 3 external ports. And you can use this device for a lot of different applications. We have the RRU 4500, the RFID reader unit. Here we have really 4 antenna ports, no antenna integrated. We have the same dual core processor to run the software directly on the device or to handle the data. So we can format the data, we can sort the data, we can do some pre-test before we ship the data, and on we can store and buffer the data with this dual core processor, depend on the application. Here again, we have a high secure memory module integrated where we have a very robust and secure way to store keys and to handle keys for cryptographic applications where it's necessary to scramble data that nobody is allowed to see the the original data. Yeah. We have the same high-speed air transmission protocol where we have a very fast possibility to catch fast-running cars or a lot of cars at the same time. We have a power over Ethernet in the same way that we said we can run with one Ethernet cable the complete unit because we supply the Ethernet and the power to the unit. With this RU 4000 family, we have an option to have a Wi-Fi version also, where we have Wi-Fi and BLE on board, where we can transmit this data wireless by Wi-Fi. Or a second option, a second version, where we have a mobile communication network built in, and we can run a 2G, a 3G, or 4G network, and can send the data in this network to get connected with the backend system. The newest device is the RU 7700. Again, a 4-port reader with a dual core processor, but on top we have a high secure memory module number 2, which gives a higher security, a faster security, and a new feature which is called key diversification. This gives you the guarantee that you can handle for each of your cars, for each of your transponders, a unique key. This is a very high secure feature. And if you want to learn more about this key diversification, please have a look with one of my latest videos we have shared. We have talked about the difference between high secure memory module number 1 and number 2 and the key diversification in detail. How does it work? Again, we have here the same high-speed air protocol to communicate very fast for fast-running cars or for a lot of cars, and we have again power over Ethernet as an interface for the Ethernet and for the power supply. All these units are allowed to use outdoors for IP67. If you do so, please keep in mind that you have to protect the non-used sockets. So all the sockets where you have cable on, and especially if it's Kathrein cable, everything is fine. You can use it, you can handle this. But if you have unused sockets, then please use our protected caps that you close these unused sockets to be also protected for the complete device. If you miss this, then it could be possible that humidity, water, or rain comes in the unit, and then it can be get defective, and for this the warranty gets lost. So keep in mind, if you use this device outdoors, if all the cables are connected, everything is fine. If you have to remove some cables because of your application, keep in mind to use the protective caps. The next component you need is an antenna. We have seen the reader is connected with the backend system. We transmit the data, and on the other side, we have the antennas, and these antennas have to communicate with the transponders. That's why we need a tool, a unit to transmit the air interface, and these are the different options we can offer for vehicle detection. The wide range antenna 7-degree is an overlane selective read zone. This means we can have a little bit more than one lane covered with this unit. We have a read range of up to 12 meters. It's a ruggedized industrial design. We have here also IP67 protection class. And we have also we have in general only one socket, though the antenna is connected, and we don't need any protective cover at all. We have a symmetrical beam of 7-degree in both in azimuth and elevation plane, and we have the possibility to mount the device for horizontal and for vertical pole mount. For the 30 by 70-degree antenna, this is a antenna with a dimension of 30 by 60 centimeters. The 70 by 70 is a unit with about 30 by 30 centimeters. And this is a wide range antenna 30-degree, 7-degree. We have a lane selective zone because in this dimension where we have a bigger dimension, we focus the beam. We have a smaller beam. We have a focus beam on this lane, and that's why we can work lane selective. We have a read range about 20 meters with a standard typical transponder. Again, a very ruggedized industrial design, IP67 outdoor protection glass, so you can run the device outdoors with rain, with snow, with sun. It doesn't matter. We have here an asymmetrical beam width with 30-degree in the lane and 7-degree in the driving direction. And again, we have here horizontal and vertical pole mounting options. Finally, we have a 40-degree antenna. This is a very special antenna because this is a linear antenna. The other both are circular. This means with the 70-degree antenna, with the 30 and 70-degree antenna, we have no problem with all kind of alignment of the transponders. We can catch them all. We have circular behavior. With a Vira 40, we have a special linear antenna. This means the transponder has to be aligned between the antenna and the transponder. The car has to arrive in a certain way. This means the transponder has to be glued, has to be sticked always in the same direction, in the same orientation. And then we have the benefit that we have a very big read range, based on the one side on the high gain, and on the other side on the polarization loss. I have an example for the polarization loss later on to go in detail with this. We have, again, a ruggedized industrial design. We have IP67, again, for outdoor use of this device. We have a symmetrical beam with 40-degree for azimuth and elevation plane. And we have also here the option to mount it horizontal or vertical. The third component you need for vehicle identification are the transponders, the labels. And here we offer typical windshield labels, which are glued inside of the windshield for cars and trucks. Gives you a very high read range for up to 16 meters if the environmental is not interfered. Then you can handle this. We have a passive function without a battery, so you don't need a battery for this device. The antenna from the reader will give the energy. You can do energy harvesting for the windshield labels, for the headlamp tags, and with this, it's enough energy to run the system. We can add some print elements or some holographic elements to give more security or more information to the user, and we have some pre-cuts and other feature to be secured against removal or reuse. So if you remove the transponder from the windscreen, it will be destroyed and can't be reused anymore. And also here we have a protection glass IP65 to run the device outdoors in cars 24/7. The headlamp tags will be used when you have motorbikes, but you can use also for trucks and cars. If it's necessary, you you glue it outside on the headlamp. And then we have a read range of about 12 meters. It's also a passive running device without a battery. We have different types of windshield labels for mono label and set folded. If you need some, let me know. And also here we have these cuts to prevent that the device will be removed from the headlamps, will be removed and will be reused. Again, also here we have a protection glass IP65. So you have seen we have all the components to be handled in the different applications. And let's start with the first application here as a multi-lane tolling free flow. This means we have 4 lanes, which can be run with cars, with trucks, maybe also with motorbikes. And of course, this can be a tolling option, tolling section, but it can be also an entry to a harbor or to a bigger area, company ground, where trucks arrive, cars arrive, and you have to cover the complete entry zone to see which cars arrive, when arrive, on which side arrives, to guide this, maybe the truck to the warehouse, or to guide the other cars to the parking areas. The typical scenario what we have here is that we have this 30 by 70 degree antenna, so wide range antenna 30-70, which gives you the guarantee that we can cover 1 lane. You see we have a typical wide width of 4 meters. With this we have a little bit less than a lane, and we can cover this. We have a distance of 8 meters, and in between, when the car is passing, we can catch the car. And in the application, you see for each lane we have 1 antenna. We have also in between 1 antenna, and this gives you really a kind of reading curtain. It doesn't matter where the car is, you can catch them, and with the information about the antennas, you know exactly at which position the car has passed, on which lane the car has passed. Yeah. Of course, this you can do on the motorway, but this can do also on a entry area of the company ground. By the way, the values you see here, the 4.5 meter and the read range and the angle, the default values. If you want to have more detailed information about your application, about your scenario, please let us know. Our team from professional service will be happy to support you from the concept phase to find out what is the best combination, which antenna, which reader, which transponder helps you best. And this can be done in a brief phase before you start with a rollout. So again, here the situation with the 40-degree antenna, you can use also for this scenario multi-lane free flow, or a big entry of a harbor, or big entry of a company ground. Here we have a 40-degree antenna, a 40-degree in both lanes, in the elevation and the azimuth. And you see here with a little bit wider than the 30-degree antenna. But here the big advantage is that we have no polarization loss. This means with a circular antenna, the other circular antenna, we have the need to split the power in 2 lanes, in 2 planes. And this splitting of two planes to make the antenna circular needs a 3 dB splitter. This 3 dB splitter has to cover also from the small signal from the transponder backwards to the reader. Yeah, and in this case, you lose 3 dB for the circular antennas. With a linear antenna, you don't have this polarization loss, and this gives you a bigger read range, or you can catch weaker transponder much earlier. That's why this 40-degree antenna can be a good option, can be the right choice for such a vehicle identification where weak transponder and weak behavior is a standard. For this plaza and stop and go application, you have a barrier, you have a boulder or something in between which can't be passed, and if you have the access allowance to pass, then the barrier will be opened, And if you have to do it manually or if you have to do it with a additional tool, then it takes time and maybe you have some problems with this. The best is to have it fully automatically freehands. This means the car will identify itself. You arrive at this area. It could be such a plaza stop and go, which are typical for tolling system, but also for smart applications, smart city application. Keep in mind what I have told before. You have a fire brigade car arriving at the area where cars are not allowed and has to enter, and who is the right guy to open this gate, to open this door. If the system is installed, you can arrive with the car. The car will identify by the system, and the barrier will be opened immediately, so without any loss of time. Here we have the option of two antennas from the ceiling or from the top. We have this 30-degree antenna, which is mounted in 4.5 meter height. As I said, these are default values, can be different for different application, but these are the default values. And when we have the 70-degree antenna, it's mounted in a 2.5 meter height with the angle of 20 degree and 45 for the 30-degree antennas. And this gives you the footprint on the right side. You see, you can do it in the lane that you see when the car arrived in the lane, or you do it from the side with a 70-degree antenna. And this you can also combine, for example, if you have cars and trucks to cover and you have different zones, you want to be sure if it's a car or it's a truck, and then you can maybe also use both antennas at the same barrier, as the same entry point. Typical scenario also for vehicle identification are parking garages, either for a public parking ground or for a company parking ground, where we have the option to be very fast and very easy to handle. In this case, we have our ARU reader, which I showed before. This means we have the reader and the antenna in one unit, a 7-degree antenna. The footprint of the antenna you see here, again, the same as you've seen before with a 70-degree antenna, because it's the same antenna integrated. We have the same mounting options, but the reader unit is combined. You can run it with power over Ethernet. You can transmit the data directly to the backend system, and you have every benefit you need to handle your application. As I said, this can be used for a public parking ground, but you can use also for a company parking ground. Keep in mind, for example, service guys from your IT has to enter the company ground 24/7. And on the weekend, maybe nobody there to open the barrier, and we have some problems with the IT system. When they arrive, they don't have to look for a key or for a certain entry point. Immediately, the barrier will be opened. They can enter with the car. So although this can be an option for such an service guy for the IT to be in the company at 24/7 when he needs to be in. So we have seen a lot of applications are available. We have a lot of possibilities, and let's come to the summary. So you have seen we have the right components for the vehicle detection. We have we can catch cars, trucks, motorbike, but also police cars and emergency vehicles from fire department and Red Cross. We can catch buses and taxis from public transportation and can handle this, can collect the data, for example, for the buses also to have a timetable, an update for the timetable. When will the next bus arrive? You can use and can transmit the data, and more it will be done. And you can have it for parking cars, either for privately used or professional use cars on a company parking lot or on a company premises. So you see, based on these basic components, we can build up a lot of ITS application for different use cases, and can give you the possibility to have access control. We can do vehicle registration, vehicle identification for a lot of different use cases, including payment services. If you have to come security, also for this we have a solution. Though the Kathrein readers and transponders meet the highest security requirements. If you have questions about the high secure memory module and the key diversification for reading scrambled text and handle scrambled text and cryptographic text in a right way, keep in mind and have a look to our previous tutorial, which we have recorded earlier. It's available on YouTube and our channel. Have a look, and I would be happy for feedback from your side. Many thanks for your attention.